So, we're just going to cover a little bit of chapter 9, not all of it, okay? It's not going to be on the final, but you will have a quiz. Okay, so we'll.
So it's like constructions.
Quiz grade. It's not, yeah, it's kind of like the constructions quiz. So it will be averaged in. So if your quiz average right now isn't where you want it to be, then you have another opportunity to raise it before we continue on with the other material. Okay, so I mentioned that it might be helpful if you have a ruler. The ruler isn't necessarily for measuring, it's just more for just making the line straight. Okay, so that's why I had, if you guys have a note card or just something, you can use your phone if you want. Okay, so let's take a look. The first transformation we're going to look at are reflections, okay, as a reflection. So a reflection is a transformation, okay, so it basically takes a shape and it flips it across a line. Like if you look in the reflection, you see it back, right? Reflection. So basically, here's what we have. This is our original, and you'll notice, remember how we did the constructions and I showed you the A prime, B prime, D prime, and E prime? Okay, that's basically the result after the transformation. So whenever we see like A prime, this is the result after the transformation. What's transformation mean? Just think about it in general. What is a transformation?
Like something that's
Okay.
transforming, something that changes into something else.
Okay, so think of this as something that's changed. Okay, so when we take a shape and we change it in some way, we can flip it around, we can rotate it, we can make it larger or smaller, okay? So this first one, if we look at, whenever we do a reflection, when we reflect it, we're going to reflect perpendicular. So you see how there's, all of these are right angles?
Yeah.
So you take, here's A, and you reflect it across the line perpendicular. So line N, this is our line of reflection. Oh, right here, this is line of reflection. A prime called A prime, that's the reflection of A in line M. Okay, and that's just after the transformation. If you look at B, it's been reflected across the line to B prime. Notice these distances, so the distance from the line to B and the distance from the line to B prime are the same. D, same thing, here to here. And E, if it ends up being on the line of reflection, it just stays there. Okay, it doesn't, it's not going to flip to the other side because it's right on the line. Let's take a look at this first example. Okay. Okay, so we're going to reflect triangle ABC across the line. What I would like you to do when you have these geometric shapes is don't try to tackle the whole problem at once. Just take the vertices. Okay, so we're going to take each vertex. Let's start with A. Now you don't have to necessarily measure. I think it's okay if you can kind of eyeball it. If you want to actually measure the distance, that's fine. So I'm going to take my ruler and I'm just going to kind of make it so that the ruler is at a 90-degree angle. Good. We're not doing construction, so it doesn't have to be perfect, but I'm going to draw a dotted line here and reflect it, and I'm just going to kind of see, well, if this was where A is, I want to make this about the same distance. Maybe I went a little bit further than I needed to.
And the distance doesn't need to be exactly.
It doesn't have to be exact. I mean, if you, like I saw there, I think I went a little bit too far below the line. There's A prime. Are we okay with that?
Mm-hmm. Yeah.
All right, next one. Just gonna, you don't have to use different colors. I'm just going to so you can see
Should
each
we
one.
put the right angle sign?
Put the A prime. Is that what you were asking?
Right angle. And
No,
the-
you don't need to draw the right angle. I'll be able to, it gets a little too confusing if you put too many markings in it. Let's look at B next. Okay, so here's B. So this is going to go a lot further below the line, right? Again, try to line it up so it makes a right angle.
Wait, but can't we just like measure it like at 4 centimeters and then do the
Well, yeah, that's what I'm saying. You can actually measure it if you want. So if I actually measured it, so
It's reflecting.
mine is about 11 and a half, so you could go 11 and a half is about here.
Okay, so I went way further than.
Right, like 3 centimeters.
If you measure, yes, you're gonna have a lot more accuracy in your picture. Your reflection is going to look more like the original. We're good with that one? Go ahead and try C. Z. Obviously, if it's closer to the line of reflection, it's a lot easier, right? Look at C. It's, for me, it's about an inch. So I'm gonna go right here to C.
Exactly the same.
Okay, now take your ruler and just connect the vertices for A prime, B prime, and C prime. So I'm going to connect A prime to C prime, A prime to B prime, and
So if I use the lessons that are like that, this will be fun.
yeah, this is, I mean, it gets
So hard.
a little bit more involved. We'll see how far we get.
This will be just dandy.
Last year when I made it, it took a little bit longer than I was anticipating, so the homework assignment, I have a worksheet that I created, so it's kind of like the constructions, we may or may not be able to complete the worksheet all at once.
You should.
So take a look at these two figures here. Okay, what do you notice about them?
They reflect each other.
They're identical, so what does that mean? This triangle and this triangle are congruent. They're similar also, but if we did this correctly, then angle A should be congruent to A prime, and B should be congruent to B prime, and C should be congruent to C prime, and also the lengths of the segments should all be equal.
That's cool.
So
How?
let's take a look. So when we have a transformation, that is congruent, we call that an isometry. Isometry is a congruent transformation. There are other transformations that are not congruent. So for example, we may or may not get to dilation. Dilation is when you take a shape and you make it larger or smaller. So in those cases, it would not be congruent because the sides would get larger or smaller. So is a reflection an isometry?
Yeah.
Yes.
Yeah. And conclusion.
Why would you?
It's actually gonna be like an always, sometimes, or never question.
It could be, but I don't have any always, sometimes or never.
Yeah.
Maybe I should throw a bonus.
No, no,
one in.
no. just kidding. Oh, bonus, it could be a
Yeah,
bonus.
no, bonus one.
Okay.
Bonus is fine.
No, bonus is not. Yeah.
No, bonus would be fine.
All right, guys, let's look at reflections in the coordinate plane.
Well, yeah, no, always, sometimes, or never, yes.
Oh,
Okay, reflection in the x-axis. So what if we're on the coordinate plane? It's actually a little bit easier when it's on the
Yeah.
coordinate plane because
Because
all
you
the
just
lines
measure.
are already there.
Oh,
So when we
so it's
reflect in the
graphing.
x-axis, so if you have a point A comma B, all right? Imagine if you had a point on the x-axis, like let's say, don't draw it on here, but let's say you had 2, 3, that point. If we reflected it in the x-axis, it would just be flipped down here to 2, negative 3.
I thought it was like
So
hardcore
basically, if
graphing.
Hardcore.
Same.
So basically, the y coordinate changes sign. Right, so when I say it changes sign, it could go from negative to positive. Kind of imagine if I had a point below the axis, right? Don't draw that on your paper yet. But if I had it here and I reflected it in the x-axis, it would land up here. Okay, so it would go negative to positive. Question?
You know freckles for Allie?
How about at the end?
Okay.
Okay.
Allie, stay
Is
for
it
the
always
end.
the y coordinate?
It's, with the reflection in the x-axis, it's always the y coordinate, and it's just the y coordinate. Nothing changes with the x, because it just gets flipped upside down, so the x coordinate, it doesn't move over. So take a look at, let's draw triangle KMN. So I have 2, negative 4, so here's K. And then we have negative 4 comma 2.
Wait,
Wait,
No, that was-
isn't it supposed to
yeah,
be
that was
like
negative
this?
2,
Oh,
negative
thank you.
4.
Yeah, I was like.
Alright. Thank you,
Huh?
I'm glad you caught that. 2,
Were
negative
you
4,
just
let's
making
try
sure
that
we were
again.
paying attention?
Yeah, that was, And then negative 4, 2. Did I get this one right? M.
Yeah.
And then N is negative 3.
We're paying
Negative
attention
4.
now.
Yeah, because this is relatively, I don't want to say basic, but this,
It's basic.
I'm hoping this will be another easy A on your next quiz.
I'm hoping so
I
too.
didn't get an A.
Oh.
It's okay.
I'm sorry.
You can give me an A. You can give me a simple
If you're like,
A.
I'm sorry, I didn't mean to make you feel
in this
bad.
case, if your face went from
I'm
like
so
all
sorry.
happy and cheery, and then it got like really sad really fast.
Oh, we just
I'm so
connected.
sorry.
Oh my god, that was hilarious.
Okay,
That looks really funny.
let's take a look at the transformation. So for each of these points, now you could use this rule, just switching the y coordinate, or you can really just count. For example, here's M. It's 2 spaces above the x-axis. So I'm just going to keep going, another 2 spaces below.
Ooh, they cross
I just-
each other.
So here, now I don't need to draw the dotted line. Don't bother drawing the dotted line. It's not really necessary here because I have the coordinate plane. So this is going to be,
So,
This
this
is-
is kind of exact.
I would, listen, if you have a different color, great. If you don't, if you have a pen, it might be helpful to draw it in a different color. But as long as you're labeling the points with the prime next to it, then I'll be able to follow in terms of your homework and test quizzes. Okay, so now we have to go for N. N is below the x-axis, so where's this going to go? Above. How many spaces? 4. So it ends up landing here. So here's N prime. And then how about K? Same thing, right? It's going to go up 4 to get to the line, and then go another 4 units. So here's K prime. And these two figures, they do overlap. That's fine.
It's actually really
It's fun. Fun math. Who knew?
This is fun math. So, what a reflection means, if I were to take my paper and fold it along the line of reflection, so in this example it would be along the x-axis, what would happen with our two shapes? They would overlap. They would basically connect. So like these two would match up. We call that a mapping. It would map onto itself. Okay? All right, next one. How about you guys try? Oh, this one is just x-axis or y-axis. So a reflection in the y-axis switches what? This switches the x coordinate, excuse me. So changes, so the x coordinate changes sign. Because this time, here's my y-axis here. So now it's going to go across instead of up and down. Go ahead and graph your triangle. So we have 5,
Isn't
3.
this just the same thing sideways?
Yep. So here's A.
Oh, never mind.
So negative 3, 1. Here's B. And 4, negative 2. Here's C. Okay. So now go ahead and do the next one. Yeah, go ahead and draw. Right, this one goes across. So if A is over here at 5, 3, it becomes negative 5, 3.
That's what I.
Okay, so here's your A prime.
No, why can't you do it downwards?
Yeah, I did it downwards.
Okay,
Well, that's
but
wrong.
if you read the directions, what are we doing this time? We're reflecting it in the y-axis. The y-axis is here. So now we want to reflect it this direction. Okay, so everything gets switched the other way. So here's B. B is 3 units to the left of the y-axis. So we're going to go 3 to get to the y-axis and then 3 more. So here is B prime. And then C is over here. You can also just change you can change these coordinates. Like just change the x coordinate to a negative. So if I look at C prime, I get -4, -2. The y coordinate doesn't change. So I'd have -4, -2. So here's C prime. Do you see that? So you could either just look at the spaces on your graph, or you could go and you could change each of these. So here, A prime is -5, 3. B prime would be +3, 1. No. Good? Everybody okay on this?
Oh my god, yeah.
I enjoy a pair of slacks.
A nice skirt too. And a banana.
Okay, next one. Reflection in the origin. Okay, where is the origin? 0, 0. If I reflect something in the origin, we switch both the x and the y coordinate.
Why?
So a reflection in the origin is like if I start with anything, remember quadrants, quadrant 1, quadrant 2, quadrant 3,
So
quadrant
it
4.
depends on where you started.
So it depends on where you start. So for example, if I start in quadrant 1, I'm going to basically go directly like diagonally. So if I start in quadrant 1, it's going to end up in quadrant 3. If I started in quadrant 4, I'd end up in quadrant 1. These two basically switch across.
What did you want?
Oh, because like A and B.
So think of a reflection in the origin as like a reflection in the x-axis and the y-axis combined.
Should we just not think about the...
So we're gonna change x and y signs. So let's draw the first one. So A is at -3, 5.
It's a very thin triangle.
Yeah, it is. Yeah. Okay.
Okay. So here is
Judge the
Yeah.
B is 0, 4, and 4, -1.
In this case, there's like barely an angle
I know.
at the bottom.
Equality for
Okay.
all.
What kind of triangle is it?
Equality. For all triangles.
Yeah, all numbers are good.
All numbers are equal.
They're all important.
What's the problem? It's a triangle.
It's a very thin
I know, they're
triangle.
all
What's
being
wrong with
judgmental.
Why?
Equality for all
There are
triangles.
no...
Skinny, fat, blue, black, I don't know. Equality.
Okay.
I'm so glad we got that on video.
Yes. Okay, so let's do A. If it gets a little confusing, just go look at A. A was -3, 5. So A is going to become a +3, -5. We switch the sign. We don't switch the order. We just switch the signs. So it becomes 3,
So both of them are
-5.
switched instead of just one of them.
Yeah, both of them switch. Because a reflection in the origin is a reflection in the x-axis followed by the y-axis.
Don't...
What do you think? 0 is right on the line, so 0 stays 0. So it just becomes 0, -4.
-5. Oh.
Ne-
I thought we were doing the first one still.
Okay. And then what's C prime? C prime becomes -4, +1. Good. So -4, +1. Here's C prime. And then go ahead and connect them to draw the triangle.
Probably gonna be him.
Cameron, what are you doing?
Who knows? Cameron does a lot of things that we don't know what he's doing.
I just did.
I understand.
Wait, what? -4, +1.
I did it.
-4, +1.
What did I do wrong?
I do not know. You get it?
I do know what I did wrong.
I'm glad you do.
I like this.
I'm
You
glad
like this
I
so
did.
far?
Yeah, so
I
far.
like the old one.
I like it better than the compass.
Can
Are you kidding? Constructions are fun, especially when you get to 22 out of 20 on the quiz.
All right, guys. Line of symmetry.
Who are you?
Minus symmetry.
Line of symmetry. So a line through a figure, a line of symmetry is a line through a figure that separates the figure into two mirror images. So, for example, if you can draw a line somewhere within the shape, and if you fold your paper along the line, they map onto each other, okay, without anything. So for example, like if you take like a heart shape, right, if it's a perfect heart shape, you could draw a line of symmetry right down the middle, and then you could fold it, and it
like
would,
an infinite number?
okay, so, no, there's not an infinite number. Okay, let's look at the first one. What do you think?
Straight line and you just keep rotating. There's 4.
No, 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 no. The way that the picture is drawn. So let's look at, it kind of looks, let's see.
There's like so many ways you can do it though.
It looks like
No, 2. 1.
Yeah.
2.
one here. Okay,
I got 4.
hold on.
2. Guys, the lines aren't the same length.
There's one here. Do you see how these are a little bit longer than the ones going this way?
No.
Yes.
Look on your paper. Do you see?
No.
The, yeah.
Turn it sideways and look at it.
These,
I'm
this,
obviously blind.
there's 2.
take your ruler and measure then. You'll see.
So
This
there's
is longer. Okay, so there's one.
Haha.
There's two.
And you can go sideways too.
But
You also do sideways.
sideways where?
Because those 2 aren't the same.
I'm saying you do it.
Are you thinking like this? Okay.
And they're not opposite.
This is longer though than this little piece.
Yeah, but
If they
each
were-
one has a longer piece.
No, look,
Yeah.
if you go to this, then these two, look, one long one and one short
Yes,
one.
bro, if you folded over the long one.
Right, okay, so I see what you're saying. So you're saying this way, but this is a long vertex and this is a short one. Those don't, they're not, this one's gonna go past. Do you see that? So how many?
2.
2. Okay, let's, for this one, let's assume this is an equilateral just for,
Did you tie that bow tie?
assume it's equilateral, otherwise it makes the problem different. What do you think?
I think there's
3.
3. So we could draw one here, one here, and here, 3?
Yeah.
Okay, that's good.
Are we gonna get through this entire thing today?
No.
Okay, good.
Wow, Cameron.
I think we could.
And
Yeah, there's. Well, we don't want 20.
Can we leave for
There's 20 minutes left.
Can we
Live.
start
Yeah, we do homework.
Okay, let's start that now.
Yeah, I can't do it anymore.
When?
it's not my problem.
All weekend.
Okay. Translation. Let's do a little bit more and then I'll give you the worksheet. We probably won't get through all of transformation. Waiting.
Guys.
So a translation. A translation is another type of transformation where it moves. It moves all points the same distance in the same direction. Okay, guys, please. So take this next one, triangle ABC, and we want to translate triangle ABC to the right. So we need a direction. We have a direction, and we have a distance. That's what we need with a translation, a direction and a distance. So use your ruler if you have one. If you don't, just share one. Obviously, I can't measure 2 inches because that won't work right on mine. So maybe I'll go.
Wait, couldn't you also reflect with
Henry, how you doing?
I'm waiting. Yes, yes.
I was just like,
Henry, how are you?
reflect this.
Henry's having a hard morning.
Compass.
Henry's doing good.
Okay, this a translation
Yeah.
is not a reflection. A reflection flips it. You'll see in a minute.
Yeah, I know, but couldn't you also do that with the compass?
Okay, I'm gonna move it
He's
over.
having a hard time grasping it.
Hold your ruler, okay, and measure from B, measure out by about 2 inches. So I'm gonna
Can we
use,
do exactly 2 inches?
you could draw,
I
actually,
did exactly 2 inches.
I'm going to draw a dotted line. Guys, can you stop, please?
Oh, we're supposed to do ground.
It doesn't matter if you, did you use a solid line? It's fine. There is B prime. So from B to B prime, I measured 15 inches. You'll be measuring about 2 inches. Now take your C. Do the same thing. You're going to measure out 2 inches from C. So here is my C prime.
Let's do exactly the same.
And then let's go to A. Measure out 2 inches. And that is
Okay, so then you're 4
A prime. Now draw your triangle.
Where's this a figurative proof?
Guys, is the middle dotted line in front or behind your triangle?
Okay, so
Is it a gold triangle or a black triangle?
you don't have to use a dotted line. I would like to see some kind of line, whether it be maybe a lighter line that you draw or a dotted line, but do something so I could see that you actually took a ruler or
Right.
something like that and measured out. So these two triangles should look identical again, as long as you measured and you went in the same direction. What do we notice about the dotted lines? They all appear to be parallel. They're not only parallel, but they're also congruent. These are the same distance, right? They're all 2 inches. Okay, so on the coordinate plane. On the coordinate plane, what does this look like? So when you translate point,
Nice.
so if you move something to the right, so if you move a point to the right, you're going to add to the x coordinate. If you move something up, it's going to be plus b to the y. So anything that's moving up is going to add to the x. Anything that's moving to the right, you're going to add to the x. Anything that moves up is going to add to the y. Well, what's the difference between that and moving left or down? That just means you're going to subtract. Okay, you could have a combination of adding and subtracting. But whatever your result is, right, your shape should still look identical after the transformation. So let's look at the next example. Let's go ahead and graph. Let's graph the original. So on your papers, go ahead and graph the first triangle that's listed. No, okay, right here, guys, right here. You'll see. The translation is actually written out for you. So start with the first triangle. Here's M. J is -5, 2. And then 0, 4. Okay, so here's my original. Now I'm going to explain to you that there are 2 ways to do this. One is just you could plug your point into.
Yeah, you're right.
Come on. Nice.
Guys, you really get distracted way too easily. Okay. Now. All right. So next I want to look at the transformation, which is going to be adding 1 to x and subtracting 3 from y. Now,
So we have to go right and down.
so I'm going to show you, if you have M, I'm going to show you 2 different ways. One is to take the point and just plug it into our translation that was provided. So if I have negative 2 plus 1, we'll get a negative 1. And then if I have negative 2 minus 3, I get a minus 5. Okay, so that's one way where I would just plug it in. I get negative 1, negative 5. So here is n prime. Or just look at the translation. So what Elad said earlier, right? Looking at what happens when you add or subtract to the x, that moves it over. Since it's a plus 1, that means we're going to go what direction? Right? So we're going to go to the right 1. And then adding or subtracting to the y moves it up or down. Since it's minus 3, we're going to go down 3. So if you look at this one, if you already have the graph, this is probably easier to do, right? Start at m, go to the right 1 and down 3. There's your m prime. Okay, j, we go to the right 1, down 1, 2, 3. And then p, we go to the right 1, down 3. Here's p prime. And then you can draw your picture. Obviously, I think just interpreting the translation and moving, I think that's easier.
They call us honors for a reason.
Can we do the worksheet?
Okay.
There's a large break after this one in the paper. I'm pretty sure that's the stopping point.
This is going to be where we stop. So in this next example, so I gave you the transformation and I gave you the translation, but I didn't give you the original. So I gave a prime, b prime, c prime.
So it's just minus 2 plus 3.
We're so smart.
Wow, amazing.
Wow, guys.
So go ahead and graph. Cool. Find the
I'm not gonna
coordinates.
lie here, but we are done.
Find the coordinates for A, B, and C. What would be A? Do you want to graph it? Do you want to put it on the graph first? Are you doing A prime, B prime? So 0, negative 3, here's A prime. 1, 6, here's B prime. And 5, negative 1, here's C prime. Okay, so right, if my translation was x plus 2, y minus 3, to find A, I want to do the opposite, right? If it's a, right, so I'm thinking, if this is it, I'm going to go the opposite. So I'm going to do a minus 2 and y plus 3. So left 2. And to the, sorry, that was supposed to be up.
Higher lessons.
Yeah.
Really?
That's why I said chapter 9 is pretty
Well, why can't you subtract 1 and go up 3?
Why can't I subtract 1?
Because the last formula was x plus 1.
Well,
Y
the translation
minus
changes every time. Okay? So I'm going to go left 2, up 3. So here's your A. B, left 2, up 3. There's B. And C to the left 2, up 3. Here is C.
I was off.
What do we notice? Do we think, would you say this is an isometry? Do they stay congruent?
Sometimes.
They should. They should look identical. Okay, let me give you the worksheet for.
Yeah.
Oh, actually, Jacob, can you grab that?
We have 2 more pages of this lesson chapter.